I wanted to do a quick video talking about limits and also continuity. So if you see here, we've got a graph, a little piecewise graph, and the first one, 1a, says what's the limit as x approaches -2 from the negative side? Well, of course, approaching -2 from the negative side means we're coming from over here. So it's just saying what y value are we approaching? We're approaching a y value of 2. Remember, it doesn't have to actually touch, it's saying what does it approach. So we're approaching +2. The next question is approaching, what's the limit as x approaches -2 from the positive side? So now we're coming at -2 from the positive direction. We're approaching -2. And you'll notice that's actually the function's value there. So we're approaching -2. So the limit as x approaches -2, well, if you recall, we've got to be approaching the same y value from both directions. We're not. So the limit there does not exist. Finally, f of -2, that's just saying what's the function's value. Well, of course, the function's value is, just whatever the actual, wherever the closed circle is, so that is -2. Okay. Now, the next question, then E says, is f continuous? The answer is no. It's probably really easy to see that. Of course, being continuous means it should there shouldn't have any jumps or infinite discontinuities. There's a jump here. We jump from positive to negative at that spot. Let me get my pointer here. We jump right there. So it's not continuous. Now, from a limit perspective, to be continuous, the answers here should all be exactly the same. And the limit definition of continuity with limits is that all four of these, the limit from the negative side, positive side, the limit, and the function's value, all have to be the same, and they're not. So that's why it's not continuous there. Okay, let's go down here. This is 0. So approaching 0 from the negative side, well, from the negative side you see that it is approaching 0. It's also approaching 0 from the positive side. The function's value is 0, and since it's approaching from the same y value from both sides, the limit does exist. So in this case, 0, 0, 0, and 0. So is it continuous? Yes. And it is because, I don't have room to write it, but it's because A through D are all equal. I'm just going to write A through D are equal. So if you were ever asked to prove that something was continuous, you would go through those four things. The limit from the left side, the right side, the limit, and the function's value are all the same. Now finally, the last one asks about +2. And if we go up to +2, what you'll see here is that the limit from the negative side and the limit from the positive side is 2. It's approaching 2 from both directions, but the function's value is 4. So we go down here, let's just answer that. The limit was 2. The limit was 2. The limit was 2. But the function's value is 4, so is it continuous? The answer is no. And it's because A through D, those answers, aren't equal. Okay. This is, of course, a really common AP question, actually pretty simple as well. I guess the one last thing I might say about it is just remember you can classify this point up here as a maximum. This is called a jump discontinuity. This is a removable discontinuity, and this is a jump discontinuity. Removable because we could redefine this spot here to close that circle.